So for this problem, we have ranked the substances from highest to lowest boiling point. So for 2 and 3, these two both have hydrogen bonds. So these are automatically going to have a higher boiling point than 1 and 4. So I'm going to discuss 1 and 4. So for 1, you can see there's an oxygen atom here, where a carbon atom is in 4. This oxygen atom has a higher mass than the carbon atom in number 4. The higher mass is going to make it have a higher boiling point because it takes more energy to move something with a higher mass. This oxygen molecule is also going to have dipole-dipole interactions with the carbon atoms around it because oxygen is much more electronegative than carbon is. So that's going to have, number 1 is going to have dipole-dipole interactions, and it's going to have a higher mass. And number 4 is just going to have London dispersion forces, and it's a non-polar interaction. So that's going to make 4 and then 1.
All right, and then to solve the rest of this problem, you're going to want to look at molecule 2 and 3 and notice one observation primarily, and that is that both of these molecules, as we discussed before, have hydrogen bonds. These are going to be occurring in equal forces, so we need to actually look at what makes these two molecules different. The only noticeable difference that we have between these two molecules is that one has a branching structure, while one has a much more linear structure. You should recall that London dispersion forces can vary based on the structure of a molecule. A linear structure will have much more London dispersion forces occurring than a branch structure, due to how easily the orbitals are able to interact with one another. And so, because 2 has much more London dispersion forces, we know that it's going to have the highest boiling point. So 3 will have a lower boiling point than 2, for the simple fact that it has less London dispersion forces, while 2 has more London dispersion forces.